Welcome to this video where we'll show how to calculate the far field radiated from a simple feed chain created in CHAMP 3D from the Feeds and Waveguides tab. As starting point, we'll use the device that we created in a previous video that showed how to set up ports and devices in CHAMP 3D. That device consisted of a transition from a rectangular to circular waveguide, followed by a 90-degree bend. Here we have added a 3 cm long circular waveguide sections, as you can see. We'll use mode matching to analyze the straight section. Devices that radiate are called aperture devices. We will create an aperture device with a single aperture that is connected to the aperture port of the straight waveguide. Circular symmetric aperture devices, circular symmetric open waveguide. Choose the existing frequency object and the aperture port. Create new MOM setting for analysis settings. As always, convergence should be checked once the calculations are made. The waveguide wall thickness is set to 2 mm and the waveguide exterior length is 5 cm. We choose power normalization to be directivity. Other choices are gain, where losses are included, and realized gains, which accounts for the reflection coefficient at the input port. If no normalization is chosen, each incident mode will contain half a watt of power. Select the combined device and choose Devices to add the aperture device to form a new combined device. The combined device has now two ports, input port and aperture port. We want to excite the former with a fundamental mode. To this end, a waveguide mode object is created. Select Create Waveguide Mode Selectors. Here, various waveguide modes can be chosen. We choose Rectangular Waveguide Mode and select the indices corresponding to the TE10 mode. Specification of objects that are related to field calculations take place in the Antennas and Scatterers tab. The field radiated by a device with an aperture is calculated by a class of the type radiating device. Select Electrical Objects, Other Sources, Radiating Device. The device of interest here is our combined device. The port excitation is at the WR90 input port, and the exciting mode is TE10, which we just defined. Now the radiating device can be seen. We need to create a field storage object, and we select a spherical cut. We set the sampling to 361 degrees in theta and from -45 to 45 degrees, while we choose a phi plane equal 90 degrees. The command that we used in our previous project for calculating scattering parameters is no longer needed and can be commented out. We now need to create a command, and we use the getField command, where the radiating device is our source and the spherical cut is the target that specifies where to compute the field. In the Results tab, we can now select Job 02, where we can see the far field pattern in the 90-degree plane. We see an asymmetric pattern, which is caused by the higher order modes that are being generated in the 90-degree bend. The directivity is around 11 dBi. I thank you for watching this video, and I hope you found it worthwhile.